Other options for adding organic matter, you can do it through cropping or managing your residues. So purpose grown crops, green manure, plow down crops, is just simply using a rotation to grow a crop that gets, rather than harvested, gets plowed into the soil to boost the organics. If you plant a nitrogen fixing plant in that plow down crop, you can also enhance the nitrogen levels in your soil. Managing your harvested crop residues. So for example, with grain, rather than taking the grain and the straw off, you would just take the grain and leave the straw there as a crop residue that gets turned into the soil to build the organics. And then with livestock feeding, there are all manner of methods which have become popular in the last few decades for in-field livestock feeding. Bale grazing, swath grazing, chop, roll. It's basically just moving your livestock and their feeding out onto your fields, allowing all the residual feed plus the livestock urine and manure to settle into place, and that builds the soil carbon to a really significant degree over conventional feeding where you would have animals penned and then collecting the manure and spreading it at a later date. Agroforestry practices can add organics to your soil. So shelter belts, hedgerows, riparian buffers, other integrations of trees and shrubs on two fronts. So leaves and litter fall from those trees, land on the soil surface and decompose. And then, as we discussed earlier, very large shrubs and trees have a lot of root mass, and up to 50% of that can be root hairs, which turn over on an annual basis. So you're getting a very large amount of soil organics added from agroforestry. Managing your grazing. This is just a matter of feeding your livestock, but also feeding your soil. So set stocking rates to leave a minimum 25% stubble or litter. I've had some producers who have told me that they will leave up to 50% stubble and litter. So you'll have to find a happy medium for yourself. Those are just rules of thumb. But in all cases, by leaving a little bit behind, and that's also mixing again with livestock manure and urine as the animals are feeding on those pastures, you're feeding the soil with organics. Rest and rotate your pastures and rangeland. Using intensive grazing, so short duration, high intensity grazing, can enhance organic matter deposits if it's paired with the right vegetation complex. So some plants are definitely stimulated by grazing, and so heavy uniform grazing use will get you better plant growth and also still have that contribution and incorporation of organics into the soil. With some plant species, it can be detrimental. So you really also have to balance out the potential for organic matter additions against the risks of compaction when you have intensive grazing. You have a large herd on an area for a shorter period of time. If the timing relative soil moisture is not appropriate, then you can get soil compaction, which negates any of the tilth benefits from the organic additions. And finally, before we leave the topic of adding organic matter, just a little discussion around should you compost or not compost. So there is no real right or wrong answer. It really depends on the factors you're trying to balance. In situ or in-place decomposition, that could be from infield feeding, crop residues, directly adding raw manures, they generate transient biochemicals that are beneficial to tilth as they decompose in place. So they're giving off starches and polymers and organic acids, which help in that good soil aggregate building. Finished compost, well-rotted manure or crop residues do not add as many, because some of that, before it got to the field, has decomposed and broken down to simpler structures. And an elemental carbon addition, so something like biochar, adds none directly. So it's more or less at a stable state with nowhere to go in terms of decomposition. So you do get those beneficial biochemicals by allowing the organics to decompose in place rather than decomposing them and putting a finished product onto your field. But the less decomposed, the greater the risk for off-site environmental effects without some careful planning. So if you think about seasonal feeding areas, for example, a lot of manure and residual feed builds up in layers of snow and ice over the winter, and if you haven't placed your seasonal feeding area appropriately. Come spring, when that melts, all of that manure and nutrient source can wash away in the runoff. So again, it's about trying to find a balance between those soil building characteristics and the risk that those various substrates present. Shifting from adding to retaining organic matter. So once you've got organics in the soil, you also want to undertake practices that don't cause those organics to be lost. So we don't want to over aerate the soil, because again, this promotes rapid decomposition, and decomposition will take your organics and turn them into carbon monoxide and carbon dioxide, and they will float off into the atmosphere. You don't want to overgraze or graze repeatedly without rest. You're going to weaken your forage plants, the root size will diminish, there will be less litter fall into the soil, so and then for the plants to regrow, they have to again start to cannibalize some of the soil carbon that's there. You set yourself on a negative trajectory. And you don't want to burn frequently. So burning is a tool. It needs to be used appropriately if you want to get positive management effects out of it. So as a tool for pasture rejuvenation, you should be doing it no more than once every 15 to 20 years in the central interior. If you're burning more frequently than that, you probably have some other underlying management problems which are causing your pastures to degrade. Protect your good soil aggregates, and this really revolves around tillage and to a certain degree equipment choice. So conventional tillage can be problematic, can cause compaction, plow pans or an impermeable layer because of the weight of the equipment can form, and it will break down good soil aggregates and disrupt the roots and soil organisms. But I am not entirely anti-tillage. Tillage is not universally bad. So again, lots of examples where it is appropriate to use tillage: deep tillage to bury crop pests, ripping to break compaction layers. So often if you want to wait for that compacted soil to naturally revert itself, you're going to be waiting a very long time. So it's really trying to speed the process of tilth building along by using ripping as a tool. And similarly with heavy clay soils, adding organic matter to a heavy clay soil, you might not get the full benefit without tillage to mix that organic matter evenly within the soils in that top 30 centimeters or foot or so of soil. Otherwise, you're going to build soil on top of that heavy soil. You'll have a good layer of organics on top, but it won't be mixed through, and you won't get the full benefits of organics across the full soil profile. And tillage really is still an important tool for weed management in cropping. With the popularity of no-till varieties or solutions for cropping, one of the dirty secrets, I guess, is that they rely on pretty heavy chemical inputs for weed control. And this probably is not a sustainable practice over the long term. So using tillage on a limited basis still has its roles. So what we want to do is till smart and sparingly. You want to use the right size implement, because compaction and destruction of those aggregates depends directly on the downward force that's applied, so the equipment weight and the size of your tillage. So don't use a plow where a harrow will do the job for you. And time your tillage relative to soil moisture. You want the soil to be moist but not saturated. If it's either too wet or too dry, you can destroy good aggregates or cause compaction. If there's a large clay component to your soils, some of that compaction can take a very long time to reverse itself. There are some inorganic options for improving tilth, but they have a few disadvantages in terms of cost and practicability relative to the organic additions. So you could add sands to clays. This is really only practical on very small plots, and it will still require a considerable cost that you're going to have to invest in fuel to truck all that sand in and mix it in with the clay. I've only really seen this done on a golf course setting. And you can also add what are called polyvalent cations. So a cation is a positively charged ion. Polyvalent means it has a charge greater than 1. So examples of these would be gypsum or Epsom. Gypsum, lime both add calcium to the soil. Epsom adds magnesium. These can loosen clay particles by breaking the chemical bond, similar to what organic acids will do on those clay surface particles. So they do the job. They just come with a cost. There's very few people would have a free source of gypsum or lime or Epsom to apply to their properties. And because gypsum in particular is a byproduct of cement making, often companies that are engaged in making cement will have a surplus of it that they need to move, and so they promote it very heavily. So paying for gypsum as opposed to changing your management to build organics, one's going to be far more costly than the other. Building your tilth, adding soil organics has many co-benefits. First and foremost, it really boosts your fertility as well. Rather than just working on the soil moisture aspect, as that organic matter mineralizes, it creates a medium for nutrient exchange, and it also releases a considerable amount of nitrogen and phosphorus and other essential plant nutrients. So I give different variations on this talk, and when I'm talking to an audience strictly from boost production, soil fertility aspect, I don't really give any different management recommendations on building tilth and organics than I have given to you in terms of improving your soil moisture holding. So they really are paired and intricately linked, but that improvement in soil fertility is strongly linked to the organics and the tilth of your soil. Surface organics in particular play a very strong role in reducing erosion from wind or water. So the universal soil loss equation, about 95% of the soil erosion risk comes from bare soil. So if you have the soil covered with organics, you go a long way to reducing erosion. Healthy soils also support a greater variety of life, from the microscopic all the way up through insects and worms to small mammals. So you're benefiting biodiversity on your farm by supporting healthy soils. And obviously you're sequestering and holding more carbon in the soil would help mitigate climate change. There might be a point down the road where farms and agriculture are recognized and paid for that carbon sequestration in the soil. I don't think that would be the primary driver for my management. You should do it for the soil moisture retention, for the improved fertility and reduced erosion. And think of the carbon sequestration as a benefit that's added on and comes along for the ride. With all these options, I encourage you to be adaptive and opportunistic. Agriculture is both a science and an art. There's a lot of moving parts, so your experience is important. Learn what works for you. It's going to take some trial and error. And adopting a beneficial practice never has to be an all or none approach. So you feel free to mix and match, take advantage of opportunities as they arise. There's nothing in the playbook that says you have to go all in on one or all of those methods that I've described. Go with what works, go with what's low cost and effective for you. And be patient. Some practices can show immediate results. So as a soil moisture conservation practice, mulching on the surface will show you immediate in-season benefits. Others, agroforestry or changing your grazing practices, might take years before you see some change and turnaround in the soil conditions. The beautiful thing with tilth is that once it starts building, it gets easier to increase because of feedback loops. The organics that go into the soil boost your soil organisms. The soil organisms help to churn and mix the soil. That helps break those bad aggregates apart, which allow for better crop growth, which allow for better livestock production, which in turn add more organics to the soil. So you get these positive feedback loops, which are really important over time in elevating the level of tilth, and through that improving your soil and water conservation.